Alright, let's play a quick game. How many different colors do you see on the screen? How about now? The correct answer for both of these questions is both really complicated and surprising, and it's more subjective than you might think. If you are a native English speaker and you ever took an art class, you probably saw a color wheel divided into 6 different colors on the outer ring, similar to the hues you might see in a rainbow if we lived in a magical world where things were visible and clear-cut instead of flashes of misty nothing on the horizon. We can say the primary colors, red, blue, and yellow, and we could say the secondary colors produced by subtractive mixing, purple, green, orange. But what if I told you that not everybody would agree that those 6 colors are the fundamental colors of our world? Let's have a quick look at Chinese colors back when the Qin were swinging things. We had He, Hong, Qing, Bai, and Huang. There were also words for purple and other colors, but just like beige or tan, we wouldn't classify them as main colors. Interestingly enough, the 5 Chinese colors correspond nicely with the fundamental colors in English. We have black and white, and then the primary colors. Except there's a slight problem with Qing. Qing is blue, but Xing is green. Some of you might be thinking, oh, those Chinese and the pesky homophones, but that's not the case here. For Chinese speakers, at least in pre-modern times, blue and green were the same color. There was no concept of this being a different color than this. This might seem difficult to wrap your head around, but lots of languages, including ancient Hebrew, had no distinction. It might seem like they are lacking in some ability to visualize the world, but that's really not the case. And if you don't believe me, let's look at a counterexample. This thing has blue stripes, right? Wrong. Russian speakers would claim that the pattern is an alternation of 2 different colors. In their language, there are 7 basic colors, including goluboy, meaning light blue, and sini, meaning dark blue. They would imagine these 2 to be permutations of the same color about as much as you would imagine red and yellow to be permutations of the same color. So how do different languages end up with different numbers of colors? There is in fact a theory on the matter. In 1969, doctors Brent Berlin and Paul Kay published the book Basic Color Terms, Their Universality and Evolution. The book proposes, based off of research, not just speculating, that there is a progression of development of discretion that is present in all language. They noticed that the maximum number of basic color terms in any given language was 11, and more importantly, that there was a pattern in those that had fewer. In their book, Berlin and Kay divide this progression of this pattern into 7 stages, along with a theoretical stage 0. Stage 1 is the simplest stage known to human language. It is when there are only 2 basic color terms, one describing light warm colors and another dark cool colors. This doesn't mean black and white, and it doesn't mean that the speakers of those languages only see in black and white. They perceive the same colors, but don't interpret them in the same way. These staged languages do exist, mostly in Papua New Guinea, where every possible weird outlier or freak of nature in the linguistic world can be found. This stage of human development is only possible after that theoretical stage 0, in which no specific colors are distinguished, only that one object is in fact a different color from another. Stage 2 describes languages that have only 3 color terms. This is where the pattern begins. Berlin and Kay discovered that any language with only 3 color terms will have red, black, and white, though again, these 3 encompass many more hues than we would expect them to. Because this is a progression, no language could ever have black and red as their only colors, because they would have to go through stage 1 before reaching stage 2. Stage 2 languages exist mostly in Africa, which is why you may see lots of African art that is primarily black, red, and white. Stage 3 languages have all of the colors of stage 2 languages, plus a 4th that is either green or yellow, but not both. It is not until stage 4 that languages will have both yellow and green, but they will always have both yellow and green before they will have this distinction between green and blue, or any other color besides the approximate black, white, and red. Stage 3 languages are fairly spread out, but one particular example of note is Homeric Greek. So if you're thinking that these languages with far fewer different basic colors are for primitive peoples, remember that the glorious Odyssey was written in a language that only had 4 distinct colors. Meanwhile, the Inuit language of northern Canada and Alaska is stage 4, making its color scheme more complex than Homer's. Stage 5 languages are the first ones to have a distinct blue. If there is no red or green or yellow, there won't be a blue, but besides red, green, yellow, black, and white, there won't be any other colors that occur until a distinct blue develops. Stage 6 languages have a brown color present, and it is only after a language has more than 8 basic colors that we finally have purple, orange, pink, maybe gray. These are stage 7 languages, and English and Malay are considered examples. It seems like a nice trait in human language, but there are some flaws. The first question asked is related to the fundamental topic of the study, determining which basic colors come into being. This requires one to explicitly define what a basic color is, and even with Berlin and Kay's definition, it's not always simple to determine what qualifies. Okay, so let's look over the technicality of it all. There's still some problems. One is a particular language called Yele, spoken in You guessed it, Papua New Guinea. Among other distinguishing factors, Yele does not perfectly fit into any stage. The idea behind the scheme is that there are a certain number of terms used to classify all colors, meaning that if you look at the color wheel, you can randomly select any RGB combination and define it with a basic term. While Yele has 3 colors and should therefore be a stage 2 language, those 3 colors do not actually define every color on the color wheel. Instead, inventive adjectives are created to describe the missing pieces. This skewing from the pattern brings us to a final problem, one which involves the fact that we use English terms to describe the development. We say that a language develops red, then yellow or green, then blue, then brown, and so on. But, like our friend the rainbow, reality is not as simply colored as we think. Many languages are different from our own, not just because they include greater or fewer divisions, not just because blue and green are the same, or light blue and dark blue are different, because they draw the borders slightly differently. Let's turn back to Russian, specifically to Goluboy, the color we would call light blue. Unfortunately, Goluboy isn't exactly light blue. The subclass of colors we would define as cyan seem like a type of light blue to us, but to the Russians, cyan is not Goluboy. If we look at a smooth, unbroken color wheel, in essence an objective display of the different colors visible to the human eye, and try to divide it into the 7 basic Russian colors, the boundary between light blue and green won't match the boundary between blue and green in the English version. While Berlin and Kay found the focal hues of each color were similar, the slight mismatching does raise questions about the potential linguistic bias in the original study. The idea behind all of this is for you to once again see just how diverse it gets out there. Even something that seems so concrete and fundamental to the world around us is wholly subjective, with different languages and even dialects each having completely different color schemes that are impossible to practically match with one another. Besides, in the end, when we delve from the real to the hypothetical, we have to throw Berlin and Kay's development to the photonic wind. Just look at the spectrum of colors and think of all the ways we could divide and interpret it. You could create a color system in which the basic terms are based primarily off of chroma, or in which the colors become more specific as the colors become warmer. So as you look around the world, think about all the different possibilities, the near infinite variety of understandings that can arise from any random, singular perception.